Let's start with the seventh question. Here it is given integration x sine inverse x dx. So according to the priority, sine inverse should be that is inverse trig have higher priority than algebraic. So your u will be sine inverse x, your v will be x. So u integration by parts, uv is u integration v dx minus derivative of u with respect to x integration v with respect to x whole dx. So sin inverse x integration x dx minus integration sin inverse x dx. Sorry, we wrote we did some mistake. Sin inverse x integration x dx minus derivative of sin inverse x with respect to x integration x dx whole dx. Yes, so it will be sin inverse x. This will be x raised to n plus 1 upon n plus 1. This will be again 1 upon root 1 minus x square. This will be x square by 2 dx. So x square sin inverse x by 2 minus 1 by 2 x square. I will write this x square as 1 minus 1 minus x square upon root 1 minus x square dx. Right, so if I divide this individually, then I will have 1 upon root 1 minus x square minus root 1 minus x square dx. So this will be x square by 2 sine inverse x minus 1 by 2. If I give individual integration, that this will be sine inverse x, whereas this is x by 2 root 1 minus x square plus sine inverse x plus c. This is of the form integration a square minus x square, whose formula is x by 2 root 1 minus x square plus a square by 2, that is 1 by 2 sine inverse x square by a square. Yes, it is the same. X by 2 root a square minus x square, that is 1 minus x square plus a square by 2 sine inverse x by 2. So if I open this bracket, then I will have x square by 2 sine inverse x minus 1 by 2 sine inverse x. This minus minus will get plus x by 4 root 1 minus x square, and it will be plus only, but 1 by 4 sine inverse x plus c. So you can see that this and this are like terms, so we have to solve that. And I will make this 4 by multiplying 2 and dividing 2. This will be 2 by 4, that is minus 1 by 4 sine inverse x, and this x by 4 root 1 minus x square plus. So I can take sine inverse by 4 common outside to have 2x square minus 1 plus x by 4 root 1 minus x square plus c. This is your final answer. Let's try to understand eighth question, where it is given integration x tan inverse x dx. Again, you can see that priority of inverse trigonometry is higher than algebraic. Then this will be your u and this will be your v. So integration u dot v, integration by parts, it will be u integration v dx minus derivative of u with respect to x integration v dx whole dx. So this will be tan inverse x integration x dx minus integration derivative of tan inverse x with respect to x integration x dx whole dx. So tan inverse x, x raised to n plus 1 upon n plus 1 will give me x square by 2. Derivative of tan inverse x is 1 upon 1 plus x square multiplied by integration of x is x square by 2, and this will be dx. So x square tan inverse x by 2, 1 by 2 will come outside, and this x square will be written as x square minus 1. I am writing this x square as 1 plus x square minus 1. This 1 and minus 1 will get cancelled, and I will get that same x square. If I individually divide this, then I will have x square tan inverse x by 2 minus 1 by 2 integration 1 minus 1 upon 1 plus x square dx. And if we give individual integration, then I will have x minus tan inverse x plus c. So if I multiply minus 1 by 2, then I will have minus x by 2 minus minus plus 1 by 2 tan inverse x plus c. This is your final answer. Next question, that is question 9. This is same as question 7. X cos inverse x dx. You know that priority of inverse trigonometry is higher than algebraic term. So this will be your u and this will be your v. So cos inverse x integration x dx minus derivative of cos inverse x with respect to x integration x dx whole dx. Integration by parts. So cos inverse x, this will be x square by 2. Derivative of cos inverse x is root minus 1 upon root 1 minus x square upon 2 dx. So cos, this will be x square cos inverse x by 2. This minus 1 by 2 will come outside, and 1 this minus x square, I will write this as 1 minus x square minus 1. This plus 1 and minus 1 will get cancelled out, and I will have this same minus x square. So if I individually divide this, then I will have root 1 minus x square minus 1 upon root 1 minus x square dx. Right. So I will make this as a 2x square cos inverse x by 4 multiplying 2 in numerator and in denominator. Right. Now this is minus 1 by 2. If I give integration to this, then it will be x by 2 root a square minus x square plus a square by 2 sine inverse x by 8. Here a is 1 minus this will be sine inverse x, or you can write minus cos inverse x plus c. Right. As you can see that every term over here is in the form of cos inverse x. So I have to convert this sine inverse into cos inverse by applying that identity. Sine inverse x plus cos inverse x is equal to pi by 2. So I will write this as pi by 2 minus cos inverse x plus cos inverse x plus this will be pi by 4 minus 1 by 2 cos inverse x plus cos inverse x plus c. Now these two are like terms. So 1 minus 1 by 2 will give me plus 1 by 2 cos inverse x. This will be pi by 4 plus c. Now I will multiply this minus 1 by 2 minus x by 4 root 1 minus x square minus 1 by 4 cos inverse x minus pi by 8 plus c. These two constant will give a new constant c dash, and I can take cos inverse by 4 common from these two terms. I am taking cos inverse x by 4 common, then I will have 2x square minus 1 minus x by 4 root 1 minus x square plus a new constant c dash. So this is your answer. Question 10, integration sine inverse x whole square dx. So here I will substitute the value sine inverse x as t. So x will be sine t, and dx will be cos t dt. So if I substitute this value, then I will have t square cos t dt. According to the priority, algebraic term will have higher priority than trigonometric term, right? So this will be your u and this will be your v. So u integration v minus derivative of u integration v, and lastly e. So integration of cos t is sin t minus this will be 2t sin t dt. I will take 2 common outside and again will apply integration by parts. So this will be 2 square t square, sorry, t square sine t minus 2. Here t integration sine t dt. This t algebraic expression or algebraic term will have higher priority than the trigonometric term. So this will be your u and this will be your v. So u integration v minus derivative of u integration v whole dt. So t square sine t minus 2 integration of cos sine is minus cos dt by dt1, this will be minus cos t again dt. This will be minus t cos t. This minus will come outside and will make it plus. So integration cos is sin t plus c. If I multiply minus 2 inside, then minus minus plus 2t cos t minus 2 sin t plus c. Now I have to replace the values too. So the t square will be sine inverse x whole square, whereas sine t will be your x, plus 2 into t is sine inverse x, whereas cos t will be root 1 minus x square. If sine t is x, then cos t is root 1 minus sine square t, which is root 1 minus x square. So cos t will be root 1 minus x square. Minus 2 sine t is x plus c. So the final answer is x sine inverse x whole square plus 2 root 1 minus x square sine inverse x minus 2x plus c. This is your final answer. Let's understand the 11th question, where integration x cos inverse x upon root 1 minus x square dx is given. So here I will assume cos inverse x as t. So minus 1 upon root 1 minus x square dx will be my dt. So dx upon root 1 minus x square will be my minus dt. Moreover x will be cos t. So if I substitute this, then cos t, x is cos t, cos inverse x is t, whereas dx upon root 1 minus x square is my minus dt. So you know that algebraic term will have higher priority than trigonometric term. So I will keep my t first and cos t second. U dot v dt is u integration v dt minus integration derivative of u with respect to t v dt whole dt. So this will be t integration cos t dt minus derivative of t with respect to t integration cos t dt whole dt. this will be, this is not the integration. This is cos sin t minus, this is 1, this is sin t dt. Integration of sin is minus cos t plus, if I open this bracket, I will have t sin t minus minus plus minus minus cos t plus c. So I will replace this value t as cos inverse x, whereas this I can write this as 1 minus cos square t minus this cos t is x plus c. Now I will keep the value of cos square t as x square minus x plus c. So my final answer is minus root 1 minus x square cos inverse x minus x plus c. This is my final answer.